Karibu SolidWorks Tanzania. Yeah, this is a proceeding of Industrial Automation series, and today we are going to begin with Siemens TIA Portal. So utaingia kwenye Google, utatafuta this one here, Siemens TIA Portal V17. This is more or less a current version of Siemens PLC. So unaweza ukaitafuta kwenye Get into PC ama you can ask around from friends, unaweza kuwa nazo and then you'll install it in your laptop. Okay? Alright. Lakini pia unaweza ukaingia, kwa sababu baadaye pia tutatumia factory ya hiyo kutengeneza visual plant, it will be looking like this. So unaweza pia ukaingia kwenye Google ukatafuta factory ya hiyo, the latest version, and download it for free, ukawa nayo in your laptop. So after you install the PLC Siemens TIA portal, you come here and then you open it. So double click on it. So TIA means totally integrated automation. So that's the meaning of TIA. All right. So these are some of the projects that has been done already. So utakuja hapo tutasema create new project. So let's say hii project tuiite kwa sababu tunaenda kutumia Siemens for logic gates. So let's say Siemens logic gates. All right. And then hapo unachagua where you save it. Let's save this one on downloads. Unaweza save it on desktop. It's okay. Let's save it on downloads. And after that, say create. Okay, ukishasema create, it will take you to another window. Right. So in this window here, unaona hapa nasema start, then device and network, configure a device, PLC programming, write a PLC program, motioning technology, configure technology, visualization, configure an HMI screen, or open the project view. So since this is our new project, so we have to choose configure a device. Manake tuna configure what kind of a PLC do we have. Ukishasema configure device, unakuja hapa unasema add a new device. And then you see we have three options here. Have controllers, so hapo tunakuwa na Siemens PLC controllers. And then tunakuwa na HMI, lakini pia tunakuwa na PC systems. So we are configuring a controller. So hapa kwenye devices you see we have Simatic S7 1200 series, 1500 series. These are the series of PLC controllers that are available. So let's choose this one, 7 1200 series, and then let's choose the CPU. So we are configuring a CPU. You see variety of CPUs here. Kwa mfano ukiselect this one utaona kuna other CPU. Ukiclick on it utaona hapa the properties of the CPU kama this is version 2.2, right? Memory 12 KB, 24 VDC volts. It will tell you it has IO, onboard IO, onboard input output interfaces, up to 3 communication modules, etc, etc. So actually a different CPU inakuwa na different properties. Kwa mfano tushasema CPU manake inakuwa ina communication interface, ina input interface, kulikuwa kuna inapokea input interface, inatoa signal kuna kwenye output interface, ina memory. Okay, so hizi version tofauti hapa za CPU zinategemea na PLC ambayo uko nayo. Kwa hiyo controller ambayo uko nayo itakuwa ina properties kama hizi. Inaweza kuwa ni CPU 1211 etc. So let's use this one, CPU 1217C DC, and then we select this one. Version here angalau iwe above version 4.0, angalau iwe 4.1, 4.2 inakuwa na better properties. Kwa mfano ukisema 4.3 utaona inabadilisha some properties here. Okay, so hii hapa ina memory ya 150 KB etc etc. Analog and digital input. So ukiona DI manake digital input 10, alright, sync source. Kunakuwa na sync source, kunakuwa na syncing input na sourcing input. So hii hapa inaweza ka play all around. Ukisema syncing input inamaanisha the source ambayo labda ni sensor ndio inatuma signal yenyewe ndio ina supply voltage. Ukisema a sourcing input maana yake sensor inapokea volts from the CPU, right? And then we have DQ6. So digital output. So kwenye PLCs, CPU, I is for inputs and Q is for outputs, all right? And then ID is for, so we have ID and QD. So QD is for analog outputs, Q is for digital outputs, I is for digital inputs, ID is for analog inputs. But here unaona inasema differential A12 AI12 analog input, no, AI2, two analog inputs, AQ2, two analog outputs on board, 6 high speed counters and 4 pulse output, etc etc. So hizi ni baadhi tu ya properties za CPU ambao tumeiselect. Then tunashuka hapa chini tunasema add. Alright. So ukishuka hapa chini kusema add, now it will go forward and open main screen for the TIA Portal window like this. So this right here is our CPU that we have configured, right? This is our CPU that we have configured. All right. So unaweza ukaja hapo kaangalia topology view, kaangalia network view, lakini hapa ni device view. Alright, so ukishaingia kwenye hii window ya PLC, Siemens PLC, unaona hapa kuna project, kuna edit, view, insert, online, etc. You see this is the name of the project ambao tumesave, what we are doing right now. So here very important sections to go about is first is the program. So click this arrow for the program. And on the program, double click on the main. So double click on the main is where now we write our ladder logics. So it'll open a window like this. This is where we write our ladder logics, right? And the other very important thing here is this thing called PLC tags. So PLC tags, this is where you write the names of the switches and sensors and counters and etc inputs and outputs. If they are digital or analog, you have to write them on the tags. So you write them on the tags and then you come back here and you write your program. So for the beginning, tutaanza kwanza kuangalia NO and NC switches kwenye PLC, Siemens PLC. Normally open switch and normally closed switch on PLC and see their properties, how they behave. So tumesema lazima tuanze kwanza kwenye tags. So tutakuja hapa kwenye PLC tags, then uta double click show all tags. So utaletwa in this window. So hapa tumesema tunajaribu kuangalia kuhusu a normally open switch and a normally closed switch and their operation principles in logic gates ama in digital electronics. So let's say we write NO switch, okay? NO means normally open switch. If you press enter, utaona inasema tag table, default tag table. Data type, this is a very important section, kwamba this is a Boolean data type. Boolean, that means it can either be a 0 or a 1 kwa sababu we are playing with a switch. Inaweza kuwa pia sensor inaweza kuwa anasema high ama low, unaona? Yes, a 0 or a 1 implies a high or a low. Then we have here the address. Now the address is also important. You see the address here is I 0.0. Manake this is the digital input 0.0. Okay, right. And then we come here and we write NC switch, enter. Again, umeona hapa tumepewa another address for input, digital input 0.1. Itaenda mpaka ikifika limit ambao ni 0.7 inaanza ina switch into input 1.0 you can according to the, inategemea sasa na CPU yako inaweza kuhandle how many inputs. Kwa hiyo kuna limits za inputs kulingana na aina ya CPU ambayo uko nayo. Okay, so tumesema I kwenye address I ina symbolize a digital input. So if we want a digital output, it's symbolized by Q. So hapa tunataka labda tuseme hizi switch zina control an LED. Okay? So let's just write here LED ambayo sasa ni labda bulb, right? Enter. Enter utaona hapa imesema ni boolean. Exactly. An LED can either be light on or light off. But then it's not an input. Kwa mfano kwenye address hapa andika I0.2. An LED is actually an output response to the switches. If either you close the switch, LED is on, open the switch, the LED is off, depending on either an NO switch or NC. So hapo uta click here, uta scroll down here, utabadilisha hapa. The identifier here is Q. So Q is for digital output. M is for memory on Boolean memory, bool memories. Okay? And then before niliwaambia kwenye registers kuna kuga na some memories ambazo zinakuwa ni temporary registers. Unaweza ukarewrite after an action has happened, etc, etc. So M keeps Boolean memories, like a memory like I'm high or I'm low. So here is Q, an address 0, address 0, okay? Bit number, let's say bit number 0, then check. So Q 0.0. Just like the I, we started from 0.0, so bit number is 0, and then here also 0.0. So after that, we are good on that. Tukishaandika tag zetu zote zinazohusiana na project ambayo tuna develop, ambayo sasa tumesema tunaweza tu a normal open switch, a normally closed switch, and an LED, right? If we want to do anything else, we'll come back here and edit these things. So we'll go back to the main, and here on the main, this is our network. So hapo unaweza ukaandika comment. So let's say tunaanza na normal open switch. So unaweza kwa NO switch working. All right. So ukiclick hapa, this is a normally open switch, right? It's right in there. Normally open contact. Closed if the value of the required operand equals to 1. Maanake normal open switch ni kama switch ya taa nyumbani, kwamba ukipush down inakuwa on, ukipush up inakuwa off. Hiyo ni normally open switch. So two ways to add it to the network. You can drag it and drop it like this, okay? Ama let me click it and delete on the keyboard. Unaweza select this network, this line, and then click on this. So two options. Unaweza anzia hapa, click on that, ama drag drop. And then now we have a normal open switch, and now this is the output. So click on it, set the bit of a specified operand, so like that. So now unaona hapa tuna normally open switch na hapa tuna output. So ukiclick in this one, unakuja kusearch hapa kwamba what's the tag. So the tag here is NO switch, right? And here, what's the tag? The tag here is an LED. Kwamba we want to see how a normal open switch works in a logic, PLC logic, okay? So after that, this is our complete network of our NO switch, right? Okay. So let's now check the working principle of this. So what you do first, so ukiwa umeshatengeneza program yako kama hivi kiuhalisia in the real world, what you do is unasema unakuja hapa unaweza kuja hapa kwenye online, then hapa kwenye simulation unasema start simulation. Itakwambia contain blah blah blah, just say okay. Alright, so this is a PLC simulator 1200. SIM 1200 sababu kule tulichagua CPU ya 1200 series without forgetting. And then you can put this here. So let's say consider this as trusted. It's compiling, right? compiling like that. Let's wait for it a little bit. Okay. So as I said earlier kwamba ukiwa this is your programming device ambayo ni your laptop, ukiwa na ile PLC device hardware, kama unataka kuhamisha hizo network zako ambazo umeshatengeneza kwenye hii software kwenda kwenye ile PLC device, you compile it, okay? You compile it and then you say download to device. Okay, so you download, manake hii program yako sasa unahamisha maybe through USB ama Ethernet cable kutokea kwenye your laptop ama your personal computer kwenda kwenye PLC device that you have. Okay, but then tukiwa tunafanya hizi project kwenye factory ya hiyo, utaona tuta start simulation. Alright, tukisha start simulation tuta compile our network. Alright, and it's great kama ukianza first kwa kucompile your network. So ukicompile inaangalia if there are any errors or faults on the network you have created before proceeding. Kwa mfano unaona hapa compiling ndio imechukua muda mrefu kufika hapa. So after that nasema load. Okay, ukisha load, ukija hapa kwenye start modules una select this arrow here, unasema start module, then unasema finish like this. So unaweza ka click tena hapa compile, right? So compile our network and utaangalia hapa chini kwamba unaangalia if there are any errors here down here as you compile. Okay, so let's compile it. Let's wait for it a little bit. Hii software kama umeifungua mara ya kwanza inaweza ikawa na some few delays on doing some actions here, lakini ikishakaa baada ya muda fulani inakuwa sawa. So we have compiled it. So after compiling it, now we download it to device. So this is our device now kwa sababu tunatumia tu simulator. So we download this network to the device. So say download, so that the network goes to the device, the CPU device that we have. So we download. Okay. Oh, wait for it. Okay, come here and say consider as trusted and then say load. Now our program, this network is downloaded to this device. Now from here we can say go online. Okay, so when you click go online, look on here, you have to see all these ones must be green. That means your network is okay and your program is fine, there's no errors. Hata ukija hapa chini complete error 0 warning 0, so this is fine. We have connected to PLC 1 via this address. Okay, this is an IP address. Hata ukienda kwenye PLC hardware ambayo uko nayo itakuwa ina address yake ambayo inaweza kusaidia communication kati ya your laptop and that PLC device that you have. After that, tuna turn this one, say monitoring mode. So mara tumeturn monitoring mode. So tunajua tumesema normal open switch ni kama switch ya nyumbani kwamba ikiwa off, the LED is off. If you supply an input, if you switch it on, then the output is on. So ukiangalia hapa power is coming from this line, from this network. We have power up to here, but our switch is normally open. So we have to close it. We close the switch so as we have an LED on. So how do we monitor that? So click on this, come to this PLC sim and click on this one, switch to project view, right? So as to toggle the switch, to joggle the switch options. Now here we see that the switch has no input, so the input is 0. to the normally open switch. That's why the output is also 0. If the input is 1, which is high, then the LED will be 1. So NO switch is not powered. Now there is no input at the NO switch. Okay. So that means it's a 0 to the normally open switch. That's why you have a 0 on the LED. If we twist that, 0 means false and 1 means true or high. Right, so we come here. On here, you select new project. Say project logic. Let's say project logic. And let's save this one to desktop, no, to downloads again, just like the Siemens logic we have, downloads. Select folder and then say create. Okay, so it's creating our project so that we can toggle the inputs. After that, wait for it. Wait for it. Okay, so you see we have sim tables. Click on this arrow on simulation table, right? On this table, click this one, sim table 1. And then here you don't see any tags, so click on this load project tags. So these are our project tags. So ukiangalia hapa, let me put this down here. All right. So ukiangalia hapa, we have a normally open switch, monitoring value false. Right now there is no input. Monitoring value is false, consistent. So you see all of these are false. The NC switch here to the connect bado, LED is false. If we toggle here, you see now the NO switch is true. Now you see the power is supplied to the LED. If we untoggle here, you see on off. So the input is true. We have a high on normally open switch, then LED will be high. If we have a low, which is false on the normal open switch, then the output is low. Manake hata kama ungekuwa na PLC device alafu umeload in network umeidownload kwenda kwenye hiyo PLC device, ukiziconnect, let's say hii PLC yako sasa ina control switching, okay? And let's say hapa kwenye normal open switch, badala ya normal open switch tuseme kuna sensor, let's say kuna light sensor, kwamba if there is light then switch on the let's say switch on, let's say light and darkness. So let's say if it's dark, switch on the light. So dark, so inakuwa high is for darkness, low is for light. So if there is darkness, switch on the lights. If there is light, switch off the lights. Unaona? So inakuwa inawaka on a principle like that, right? So most of the sensors zinakuwaga zinawaka kama an NO switch, most of them. All right. So let me minimize this. Okay, right. This is my sim table. Let me minimize it to here. Right. I'll find it. Okay, so if now I want to go to normally close the switch. So to edit your network, first you have to go offline from here. Go offline. Should go offline like this. Now I can delete this, select this one and delete. Okay, and I can drag drop and normally close the switch like that. Okay, ama hata kama bila kudelete nikaweza nika select this arrow nikabadilisha tu hapa ikawa normally open, nika select this arrow nikasema normally close. So this is the symbol for normally closed switch. So I go here and select the tag. This is the tag for normally closed switch, right? So it's an NC switch. And what do you think happens here? This switch works in vice versa, kwamba this switch is normally closed. Manake the power is always through to the output when there is no, when the input here is 0. So when the input is low, there is no input on the normally closed, the LED will be on. If there's an input on the normally close, the LED is off. Inaweza kuwa a little bit confusing, lakini take this switch as let's say a stop push button. Okay, so a stop push button ni kwamba at the beginning it's inaruhusu, let's say a machine to run, let's say a motor is running and this is a stop push button. So when you have not pushed the stop button, then there is no input here, so the input is zero. So that's why you have, let's say, the motor running. So if you push the stop button, then you are disconnecting the power to the output, so the motor stops. Okay, so unachoangalia hapa, usiangalie kwamba hii switch iko on. Switch kuwa on haimaanishi kwamba it's high. No, we are looking at the input. Is the input supplied? Kwa mfano kwenye stop push button, is the stop button pushed? If it's not pushed, then the input is low, which is false, which is zero. If you push the stop button, then the input is high, then the input is true. Hope you're getting it. So we have changed this, so we compile it. After compiling, we download it again, kwa sababu sasa ile program ambayo tulikuwa nayo kwenye ile PLC simulator yetu ambayo ni kama PLC hardware ilikuwa ni ya normal open, so we have to download it again. So load like this, and then after that we say, kwa sababu tulisha start simulation, hatuna haja tena kusema start simulation. So what we do here is just go online like this, turn on monitoring. So you see this LED is on. There is no input. The input is zero on the normally closed switch, but the LED is on. Let's go and find our monitoring. This one here. Okay. Okay. Right. So this here is our monitoring device. All right. So our monitoring device to toggle the input. So you see here, a normally closed switch is false. Okay, there is no input at the normally closed switch, but then we have the output is high, kwa sababu tumesema no input means zero or low. So if we have an input, let's say we push the button, then you see now is the LED is off. So the normally closed switch works in vice versa to the normally open. So normally hii normally closed switch huwa ina represents an inverter kwenye PLC. Kama tunavyojua, an inverter, it does the opposite of what is supposed to be. You give a high to an inverter, it gives you a low. You give it a low, it gives you a high. So unaona, so a normally closed switch is more often used as an inverter, which is used for an emergency stop, a stop button. So you push the button, it stops the power. You release the button, it supply the power. So unaona inaenda vice versa. So normally closed switch umeona hapa is true. We have an input high, but the output is low. If we toggle it again, the input is low, which is false or zero, but the output is high, which is one or true. So I hope you have captured that. Okay. Okay, now that we have done on the normally open switch and normally closed switch, now let's go ahead and look on AND gates and OR gate. So let's start with an AND gate. So here we go offline, and now let me delete this network. Just click it from here. So nilisahau kubadilisha hapa, unaweza ukabadilisha hapa comment usema NC switch working etc. Click on this network, say delete. So we're starting from the beginning. So we go back to the show all tags. So hizi input zangu hapa nataka ziwe input A, enter, and I double click here again, edit this. Let's say this is input B, enter, and let's say this is output X, output X, right? Okay, nimebadilisha my tags. So narudi back kwenye main. Ikiwa kwenye main, so I know an AND gate works like this. The output is high if and only if all the inputs are high. Kama we have two or more inputs, they have to be high to have a high on the output. So here I'm putting my normally open like this, input A, input B, then output So I select here the tag. So here is input A, lakini unaweza pia hapo ukaandika tu, badala ya kuitafutia hapa, unaweza ukaandika address. Kwa mfano hapa ilikuwa ni I, ile input B ilikuwa ni I 0.1, then enter, enter again. So you see input B hapa ilikuwa output ilikuwa Q 0.0, so unaweza ukaandika tu address Q 0.0 double enter like that, so you have output X. So this switch, this circuit here represents an AND gate, kwamba we will have an output here on high if and only if input A and input B are high, unless otherwise we have low here. So okay, so again tunai compile, we have compiled it, all right, then tunai download it to device. Usisahau tumesha start simulation muda mrefu, so tunachobadilisha tu ni ile program ambayo ipo ndani ya PLC sim yetu ambayo ina represent a physical PLC controller. So download to device and then say load. After download to device and say loading, so come here and say go online. Okay, everything turns green here, then everything looks good. Loading error 0, warning 0 looks good. This is the same address of our PLC controller. And then come here and say monitor. And then let's start our toggle button. So angalia, the output here is low. Input A is false, manake 0, 0 on input A, 0 on input B, 0 output. If we toggle input A, you see input A is 1 or high, input B is low, the output is still low. If we toggle on B, you see input B is powered, but then there is no power from input A, the output X is low. So if we power input A and input B, only if input A and input B is high, then the output is high. So that's what symbolizes our AND gate. Ni kama tulivyosema kule tulivyokuwa tunatumia AND gate kucontrol let's say kucontrol ile seatbelt alarm ya gari, kwamba ukiwasha gari, tuseme ukiweka switch on, hiyo ni input A. After tuseme tuna two inputs, switch on input A, alafu ukifanya buckling, ukichomeka mkanda kwenye lock yake, input B inakuwa low, then only if hii inakuwa zero, kwamba switch on input A high, kama uja plug in seat belt, input B pia inakuwa high, manake an alarm will be on, ama itakuwa ina blink seat belt light. If you plug in the seat belt, then the plugged seat belt, that means input B is 0. So that means you won't have an alarm or an seat belt indicator on your vehicle. So that's it about AND gate. All right, let me minimize this. Na uliona hapa hizi ziliji update, yeah, nilivyozibadilisha kule na huko pia ziliji update. So kama singeji update tungeload tu tags, kama kungekuwa kuna extra tags pia zingine tungeziload tu from here. Okay, then go offline. Now I want to create an OR gate from the same input A and B. So I can click on this and delete this. I click on this one. I click on extend open branch, and then I click on another switch, and then I close branch. That's so an OR gate is normally a parallel arrangement of your switches ama of your input. AND gate ni series, na maana tumekuwa na A.B, alafu OR gate ni parallel connection A O B, ambayo ni A plus B. So let me control Z nikuonyeshe jinsi nimeweka tena hii parallel branch. So ni select this line, nika select the branch out, nikapata this, then nika select this, ikaja like that. Hii pia unaweza uka drag drop here. Okay, drag drop here like that. Ama if I delete this, I can just click here and say close branch like that. So all of the options are fine. So hapa ni I 0.1 ambayo ni input B. Okay, now the working principle of an OR gate we know for sure. So hapa unaweza kaandika comment OR gate like this. Okay, so the working principle of an OR gate is that we have a high, output will be high if either of the input is high. If A is high, output will be high. If A is high, B is low, output is high. If A is low, A and B is high, output is high. If both are high, output is high. If both are low, then the output is low. Okay, so again we compile it. So we compiled it successfully, no errors, zero error, zero warning. Then we download it to device, say load. Okay, so here we say go online, sababu simulation tulisha start before, and then tunakuja hapa kwenye monitoring, right? Click on monitor. um I don't know why it's not responding to monitoring. Okay, let me go offline. Let me delete this. Let me try. Compile it, download it, load. Okay, monitor. Okay, unexpected has occurred. Communication error. Not enough memory available. Um, Let me close this. Do you have to change? No. Um, okay, go offline. All right, let me. I don't know what happened here. Has me misbehaved a little bit, but let me start again the simulation. Let me save this project and online simulation, start simulation. Let's start it again. Okay, consider this as a trusted. All right, let's wait for it a little bit. But I hope you have understood how we arranged the normally open, normally close, and we said the normally closed switch is normally used as an inverter. Inatumika sana kwenye push stop push button na emergency stops. If there's an input, then it sends it cuts the power to the output. Okay. Then you have seen an AND gate is a series connection of inputs. If all the inputs are high, then you have a high on the output. And we've seen an OR gate is a parallel connection of inputs. If any of the inputs is high, then the output is also high. So it's an addition. Yeah. If it holds on misbehaving, uh, we will try to sum up this session, and we will proceed on the rest of the gates on the coming presentation. Let's wait for it a little bit. Let me see what happens here. Okay, let's say start module, finish. Okay, it's like that, and then say minimize this. Say download to device, consider, load, finish. Let's see if it goes online. Everything is fine, and see if we turn on. All right, so we come back here. So let me go offline first. Acha niweke as it's supposed to be the parallel switch, right? Let me put the parallel switch first. And here, this is input B. Okay. So compile this. Okay. Download to device. Load this. Okay. Go online and then say monitor. Okay. So we come back here. We switch to project view. So we toggle the input. Wait for it. Right. Let's come there and we go to new. Okay, let me have another project here. Project Siemens, Siemens, Siemens Logics, and then put it on downloads, create. Okay, let me come to sim table, then this sim table here, and then say load tags. Okay, so now we see here we have input A false, input B false, output false. So tumesema kwenye OR gate, if any of the input is high, then the output will be high, right? So if we toggle, let's say input A high, you see we have a high on the output, right? I can switch it off. And if I toggle input B high, then you say input B is high, then you see we have a high on the output. If we turn both the inputs high, then again we also have a high on the output, right? And then if we have all zeros or all low, then the output is low. Okay, so I hope you have captured plenty on that. Also, we have seen a normally closed gate, normally open gate, I mean switch, NO switch, NC switch. So we said ND gate is series switches are in series, and OR gate is switches on parallel, right? Okay, so let's go and see NAND gate, right? A NAND gate. So a NAND gate tulisema ni kwamba inakuwa ni if all the inputs are low, then the outputs are low. Okay, so tulisema kwenye NAND gate inakuwa ni vice versa ya AND gate, kwamba tulisema if all the inputs are low then the output is high, inakuwa vice versa, right? Lakini kwenye OR gate tulisema if either of the input is high then the output is low, inakuwa vice versa, right? Inakuwa vice versa of those. Na unaona hapo kinachotokea ni kwamba we will just have an OR gate and an inverter somewhere, right? An OR gate and an inverter ambayo maanake itakuwa nasema not all, right? Not all, right? So na ukiangalia not all zinaweza zikawa ni zinaweza zikawa ni not O, right? Manake unakuwa na A plus B bar, right? Inaweza kawa like that. So let me minimize this and say go offline. So if I change this, okay, say this is a normally close and this is a normally close, like that. So this will be a no gate, right? No gate. No gate tumesema if both inputs, if if um if the input here is 0 and here is 0 and the output is high, right? And then we say if any of the input is if any of the input is 1, the output should be 0. And then we have to be a bit creative on this one, so that we have a logic for a NOR gate. So nadhani zinaenda vice versa. I'm trying to come up with a logic to this. Kwa mfano hii ambayo tumeandika hapo ilikuwa ni OR gate. So kama unakumbuka somewhere in the studies of NAND gate and NOR gate tulisema kwamba NAND gate is equal to not tukisema NAND gate A B bar, okay, is equal to not A or not B. Manake sasa hii ambayo tumeicreate hapa sasa hii, this is a NAND gate. Kwa sababu tulisema kwenye NAND gate, hii ni NAND gate. Sababu tulisema kwenye NAND gate, kama unakumbuka kwenye digital electronics ukienda kwenye previous video, tulisema a NAND gate is the same as not I mean is the same. Kwa mfano NAND gate ya input A and B ni sawa na kusema not A or not B, right? And then tukasema a NOR gate ni sawa na kusema not A and not B. Umeona? Maanake hapa tukisema kwa lugha ya rahisi ni kwamba hapa ni sawa kusema A bar plus B bar. Hiyo ni sawa sawa na NAND gate. Alafu NOR gate ni sawa sawa na kusema A bar dot B bar. Hiyo ni NOR gate. Na tunajua kwenye output inakuwa vice versa, kwamba tulisema kwenye AND gate if all the inputs are high then the output is high. Lakini huku sasa kwenye NAND gate inakuwa if all the inputs are high then the output is low. Inakuwa vice versa unless otherwise high. So let's try to monitor this and see what happens. So compile this network and download it to device like that. Say load, all right, and then say go online. Okay, say monitor. So you see, let's bring our table here. So unaona all the inputs are low, you see false. If all the inputs are low, the output is high. That's a NAND gate. If any of the input is high, then the output will be high again. So let's toggle this. You see, still we have the output is high. Okay, if you toggle this, you see the output is still high. But if all the inputs are high, input A is high and input B is high, which is a true, that is a signal, then the output is 0. So that's a NAND gate. All right, so let's go offline and go ahead look for which gate? NOR gate. So a NOR gate, so I'll just delete this I'll come back here and add a normally close like this, and here I'll have I 0.2. Is it 0. No, 0.1, which is input B. So this one is a NOR gate. NOR gate. So tulisema NOR gate is equal to not A and not B. Okay, A bar dot B bar. That's a NOR gate. So what's the principle? The principle is if any of the input is high, the output is low. Unaona? If any of the input is high, the output is low. If both of the inputs are low, then the output is high. That's the working principle of a NOR gate. Utaenda kwenye hiyo video ya nani ya digital electronics presentation number 4, and then we can confirm more about these operations. So here, let me compile it again and say download it to device. Say load, okay, and then say go online and say monitor. Okay, so let's bring our table here. So you see all the inputs are low, the output is no, all the inputs are high, the output is low. I mean, so that's kwa sababu iko toggled here. Let me uncheck this. So if all the inputs are low, the output is high. That's an operation of a NOR gate. You see here, input A is false, input B is false, the output is high. But if any of the input is high, the output is low. Or you can toggle this one, see the output is low. But if both are high, then it's low. But only if both the inputs are low, false here, then the output is high. I hope you have captured that. Okay, so let's finish up with the gate. So the gates that remain here is an exclusive OR gate. All right. So if you remember an exclusive OR gate, tulisema kwamba um, tulisema kwamba if the inputs are different, then and only then the output is high. If the inputs are different, then both, then we have a high at the output if both the inputs are low, right? If if the inputs are different, then we have a high on the output. That's an operation of an exclusive OR. So let's see how we can create an exclusive OR here. Okay, so let me minimize this, and here say go offline. So let's say we have input A and input B for an exclusive OR gate. Let's say we have input A and input B. So here I'll just change this into a normally open, and then increase another branch here, have a normally close, then a normally open, then close branch. So I say here this is input A again, and then this is input B again. Let's see if this works. Okay, let's compile this and say download to device. Say load. All right, so say go online. Say monitor. Also, I think the memory has busted again. Let me go offline. Let me close this. No. Okay, let me go to online, then start stimulation again. Okay, considers trusted agent. And say load. Okay, and here say start module, finish. Okay, let me try again. Okay, let me compile this, download it to device, consider as a trusted device, load this, and say, let me download it, load, okay, finish, and then say go online, and let me see, monitor, okay, all right. So let me go here and say, switch here. Okay, let's wait a little bit. Okay, let me say new. Okay, let me say project one, or project XO. Okay, create. Then we come here. Let's wait for it. Okay, sim table, load tags. All right. So we're finishing up this session. Um, Okay, so tumesema kwenye exclusive OR. So an exclusive, sorry, hapo tabadilisha kaandika exclusive OR gate. An exclusive OR, we have our output high if input A and B are different. Kwa mfano ukiangalia hapa input A is false, 0, input B is false, 0, the output is 0. If we switch any of A or B, then the output will be high. Let's switch this. Oh yeah, so you see input A is true, output B is false, manake 1 on input A, 0 on input B, then the output is high. Ama unaweza uka switch B, okay, 0 on input A, 1 on input B, the output is high. So that's an exclusive OR gate. Kama zinafanana kwa mfano one input A is high and input B is high, then the output is low. Or if both are low, then the output is also low. So that's an operation of an exclusive OR gate. Okay, so naona session ilikuwa ndefu kidogo, but I think you have captured plenty on this session. So until the next session, keep moving forward. Ciao.